Recording. Hello everyone, hope you guys doing amazing. So hello Aya, Bilin, Diana, Ebenezer, Givalino, Harp, Metiti, Mol, Joel, Coach, Mol Motor, Meswaki, Romaric, Sabah, Theodros, and the lazy programmer. We are all lazy. So today is the last day of week 7, and we did this, we did all of this. 2 left is this one and this one. So let's start from this one before we jump to this one. 0-1 matrix. So let's see how we can do this. Before it, let's understand it. Given an MXN binary matrix mat, return the distance of the nearest 0 for each cell. The distance between 2 adjacent cells is 1. The distance between 2 adjacent cells is 1. Okay, let's try to understand more. So 0, so 0 0, this is like, okay, 0 1 0, 0 1 0, 0 0, and then the output that we're gonna return is 0 0, 0 1 0, 0 0 0. So maybe this example doesn't make sense or it's hard to understand, but this one we can make it better. So this one we have 0 0 0, and then it's become, we return 0 0 0, here 0 1 0, here 0 1 0, here is 1 1 1 1, 1 2 1. Okay, so it's still confusing. Let's take it to Excalibur and try to understand it. What do you mean? What do you mean?
One sec, try to check the second example because it is max. Yes.
We'll try to decode them. And what was the thing is this one right here. Okay, so let's try to understand how this problem, what they mean. So given an MXN binary matrix mat, okay, here is it. Let's focus on this one because this one, actually this one is enough because this one is a bit confusing. So this is the mat they give us, which is this one right here. Mat. Okay, what about mat? Return the distance of the nearest 0 for each cell. So this cell right here, return the distance of the nearest 0 for each cell.
So itself
is 0, right? Okay, so this gonna be 0. This one, this cell right here itself is 0, so distance is 0. This one gonna be 0. This one gonna be 0. And this one, it was, the value it was inside is 1. So the, like, let's say the distance between, or like to the closest cell that's 0 is 1.
Yes, we go left and right, maybe, and up down.
Yeah, so like this cell right here, the closed zero to it is one cell. So one from here, or from here, or from here, or from here. No, not from here, because there's one. Okay, so this is the confusing part that I was confused about how this work. And it was confusing because the value inside already 1. So basically, if we say there is 20 here, the number 20, what we should return is 1, right? Because it's like saying this cell, we ignore the value inside and we just say this cell, what is the closed zero? Okay, easy. There is one closed zero here. What is the distance? 1, because there is one edge or something. What's it called? Distance between two adjacent cells. So this is two adjacent cells. The distance is 1, right? Now it have also closed one right here, but all of them have the same distance 1. So I'm gonna remove this 20. I don't care like what's the value inside. I'm gonna remove it. I'm gonna put 1, or maybe create new cell and put 1. So that's
Nasser,
yes.
I guess we should check the down cell. Because
Yeah.
even if it's one, we have to check it.
Yeah, but like we only calculate the one that have 0, right?
Yes, okay. Yeah, if we check, okay. If we check the first one and you
Yeah.
have 0, we can stop.
Yeah, we will check this one, but this one have 1, so we're looking for 0. So the goal is like we're gonna go through this matrix and we're gonna return a copy of it, but the copy of it's gonna have the distance of each 0. Okay, let's do example. So this is, let's throw this away and let's put this here. So let's say this number is 15, this number is 20, 3, 5, just random numbers, and we are going through each. We are returning the distance for the nearest 0 for each cell, and this is the one that's gonna return. And we are like, okay, let's go to the first cell. What is the closed 0? Itself. So 0. What's closed 0? Itself. 0. Itself 0. We reached the 15. What is the closed 0? We go here, 1. Okay, so if it was 1, probably we don't need to care about this one, but like let's just go 1, 1, 1. Okay, so we're gonna return 1, and then we're gonna go to this one. What's closed 0? Itself, so 0. We're gonna go to this one. What is the closed 0? The one above it, right? So 1. And also this one. What is the closed 0? Oh, wait. If we go here, there is no 0. If we go here, there is no 0. If we go here, there is no 0. But if I go 1, 2, there is 0. So 2. The closed 0 is 2. And there is 2 way. Either 1, 2 or 1, 2. Right? So choose 0.
What about the 0 in the top?
Yeah, but we're looking for the closed one.
Yes, but we have to check it. Maybe if the left one and the right one was not 0, and so the top one.
Wait, I think that also can be 2. So 1, 2. Yeah. So this, yeah, you're right. It's actually it's true. It makes sense. So 2. The closed one is 2. I guess either we're gonna find this, or this, or this, or even this, right? Because 1, 2, 3, like this, maybe. I'm not
You can find
sure.
from the zero in the.
I'm not
picture.
sure if it. I think if it was a number here. Yeah, but let's explore. But now we know what these two come from, right? And the last cell is this one, and close zero is one above it, so one. Now finally it makes sense where these two come from and why one and one. It was really confusing because the initial value of the same matrix is also one. So who did understand what is the problem and what they are asking us to do? If you have any question, please be happy to explain, or someone here can explain.
Could you repeat once again?
Okay, so is there a specific part you want me to repeat, or you are totally lost? It's okay if you are.
I'm totally lost.
Okay, so here is it. So imagine they give us this this array, right? Now let me put the numbers. Ignore this one here. Let's say there is 20, 5, 4, 3, and what they're saying is like, given an mx binary matrix, return the distance of the nearest zero for each cell. So we're gonna go through each cell, and from that cell we're gonna start looking for the nearest zero on all direction, including itself. So far, is this clear?
Yes, yes.
Yeah, so if we did just try to apply this, what they're saying on this, we're gonna end up with a new matrix that have distance that represents each cell here, right? So for example, the first node 0, what is the first closed 0 or nearest 0 to it is 0 itself, so 0. So 0, like the distance is 0. Now we're gonna go to this second one. It's also 0 because there's no distance, it's itself 0. This one 0, this one 0. Is it clear so far?
Yeah.
Now we're gonna reach this one. We're gonna ask the same question. What is the nearest 0? So we have 0 here, 0 here, 0 here. So if you go here, is 1 step. We go here, 1 step. We go here, 1 step. So the nearest one is 1 step. So we're gonna write 1. Is this clear?
Yeah.
We're gonna go to this 0 right here. It's also 0 itself. Yes.
I think also we have to check the bottom, because if there is no 0 in the left or right or top, we have to check the bottom.
Yeah, we're gonna check like all of them, but like just now visually we can see that this is 4, so like there's no need to check it. But like when we're gonna like maybe doing pseudocode or like writing solution, we need to check everything because we can't see. Now this one we put 0 because itself is 0, right? Then we're gonna go to the next one. So tell me, Michiti, what we're gonna put here and why?
Where?
Ask like 5. 5 is representing here, right? So what we're gonna write here? Do I write 5?
1.
No, it's 1.
Why 1?
Because ده اللي فوقيه 0 أقرب حاجة.
The one above it, right?
Above 0 the nearest 0.
Did you understand it, Michiti?
Yeah, and in the statement we are given where they say the distance between two adjacent cells is 1.
Yeah. So this is a cell, and this is a cell, and distance between two adjacent cell. This one are adjacent, right? This one and this one, they are not adjacent.
Yes.
So the distance is 1. So we're gonna write 1. Is that like clear?
Yeah.
Then we're gonna go to the next one. Now, what about the next one? What's gonna be the value?
I have idea here.
Okay, save
You-
the idea. Wait, let's understand the problem. Then we go to the brainstorm phase.
Yeah. Okay.
Okay, who can tell me what number we're gonna put here and why? Don't be scared.
We are going to put 2 there.
We're gonna put what?
2 numbers.
Two. Why?
Yes. Because if we go to the left, there's no 0, and we check to the right, there's no 0. So we are going to go up. For us to get 0, we are going 2 steps. So the distance to the nearest 0 is 2.
Okay, so from here, if I am going up and looking for 0, I'm not gonna find it. If I go up again, I'm gonna find it. If I turn right, I'm gonna find it. If I turn left, I'm gonna find it. So the distance is 1, 2. Okay, I find 1, 2, 1, 2. So 2, another 2, 1, 1, which is 2. So the nearest one is 2.
Yes.
So the nearest 0 to this cell is 2. So I'm gonna write 2. And the last one gonna be 1 because there is 1 above it, so 1 space. So this is basically the problem. Hope it's clear for everyone. Now
Yes.
we go to a solution. Let's brainstorm what could be the algorithm or that will be useful here. What's come to the mind? What do you think? What's come to your mind? Or any brainstorm solution you come to your mind? Yes, Mahmoud.
First check it's gonna be the 0. If the value of the set is 0, we're gonna return 0.
The value. So we're gonna check the 0.
Yes, check the number if it's 0 or not.
Okay. Check each cell if it is 0. Is that what you mean?
Yes.
Okay.
If true, it's gonna return 0.
Okay. So if this is 0, it's gonna return 0
Add 0
to the list. Okay.
yeah.
Let's keep going maybe. 0 again, it's gonna be 0. Check this, if this 0, it's gonna be 0. Then we're gonna come here, this also 0. We're gonna put 0. We're gonna go here. What we're gonna do?
So if not 0,
Maybe we can have a variable and
Variable.
we can add we can
Okay.
add to it according to the value of the item we are checking.
Item. We're gonna add to it what?
For example, I will add 1 to the current value
This
of the
one.
variable if the value is if the value of the element is not 0.
Okay, so if it is not
Until I
0,
reach this.
check if it is not 0, add it to temp variable, for example, right?
Okay.
Or hash table, or like array. Are we like gonna collect them all, or
I think what we can do is, can you hear me?
yes? Go ahead, please.
I think what we can do is to create a hash table, but this kind of hash table will
Hash
just be an array of, the hash table is an array of tuples. Now,
Array of
in each,
tuples.
yes, array of tuples. So in each of all those tuples, we have the value, which is 0, and then the index of that 0 where we found 0. So whenever we encounter 0, we push it into the array, right?
To the top,
And so
to the hash table.
yes, to the hash table, push the tuple.
Oh, okay. So for example, we found this 0. It's gonna be 0 0 like this.
Yes.
And the value.
No, like instead of us to use hash table, let's use an array instead.
Let's use what?
An array. An array.
Okay. So let's say this is our
There is
array.
no point of keeping the value because we're only going to store in the array the ones with the value 1. So we just store the indexes of the ones that are different than 0 because those are the ones that will be difficult for us, right?
Okay, so one solution say we store the 0, and one solution say we store the 1 and we leave the 0.
Okay, anyone can work.
Because we already have a condition that checks if it's 0, then it's done. There is nothing to calculate. It's basically just, and then if it's 1, then that when the work starts.
Okay, so check if each cell. Okay, check if it's cell it is 0. Well, we're not gonna add it, and if it is 1, we or like if different than 0, we're gonna add it to the array.
And
that array will just help us to store those placements of ones temporarily. It's not the final value. After that, we will construct another array containing the output, you know?
Okay, so if it is not 0, add it to the array. Check cell if it is 0. I guess if it is not 0. What do you think, guys? But still, okay, let's say we add this 3 here. 1, 1, 1, 1. What we gonna do now?
No, we will add them by the index.
Oh, okay.
Their placement.
So 0, 2, 0, 1, 2. So 1, 1. And 0, 2. And 1. I think this.
Munsaf,
Wait. Yes.
my idea.
Yes. What's your idea?
Okay. I think you can move if there is 0, add 0. If not, you can check check above and right and left. If there is 0 above or right or left, write 1. If no, if if no, if there is 1, if there is no zeros above and right and left, the لو بيساوي 1 يعني if there is 1 or more يعني and the next and not equal length, you can add 1 plus the يعني اقول لك بالعربي and
no.
اوكي بص لو فوقيه 0 وجنبيه 0 يمين 0 شمال 0 تكتب 1 تمام. لو فوقيه او لو مفيش ولا 0 تكتب بقى لو مثلا تشوف اللي هو مش 0 ده فين. لو مثلا شماله 1 مثلا، لو شماله 1 وبعد كده الشمال 1 ده اصغر من اللينس، تكتب 1 زائد الواحد هيكتب 2. يعني مثلا رقم 1 اللي في النص ده عليه كده، رقم 1 اللي في النص دوت هتتشيك فوقيه 0 تمام، وجنبيه 0 يمين 0 وشمال 0. انت هتكتب 1 زي ما هو. لما تنزل اللي تحتيه بقى روح عليه كده، هتروح اللي فوقيه 1 واللي جنبيه 1 واللي جنبيه هناك 1. فانت طبعا ما فيش ولا 0، هتتشيك بقى الواحد اللي فوقيه دوت بيساوي اللينس ولا لا. لو مش بيساوي اللينس هتقول له طبعا هيبقى
What is length؟
اللينس اللي هو 0 1 اللي هو 1 2 3 اللينس بتاع الاري كلها. ما هو طبعا هم 2 dimension array. اول واحده المفروض يبقوا قد بعض اي ثينك. فهو اول واحده يعني 3 اري، كل اري فيها 3 عناصر. فانت هتتشيك لو الاندكس بتاعه اللي هو الواحد الاري ده، لو الاندكس بتاعه بيساوي الاري بيساوي 3 يعني او بيساوي 0. لو انت بتتشيك لفوق هتتشيك ل0، لا مش هنتشيك لتحت كده، هنتشيك لفوق. لو بيساوي 0 الاندكس بتاعه بيساوي 0، اندكس 0 هنكتب 1. انما دوت ما بيساويش 0، ده الاندكس بتاعه بيساوي 1، فمعناها ان في قبليه 0. فانت هتكتب 1 زائد اللي قبليه. اللي قبليه ده لو 1 هيكتب 2، اللي فوق ده هيكتب 2. اللي قبليه
اوكي
ده لو اكتر من 1 هيزود بقى الواحد زائد اللي
اوكي
قبليه هيكتب العدد.
اوكي
انما
maybe
مثلا
maybe
ثواني،
yes
مثلا
yes
اللي بعديه لو احنا بنشيك على اليمين، اليمين دوت بيساوي اللينس اللي هو 1 تحت، لا اللي تحت 1 تحت جنبيه بيساوي اللينس، فاحنا مش هنكتب 2 عشان ما فيش بعديه 0 خلاص. والشمال بيساوي 0 فاحنا مش هنكتب 1 برضه
when
عشان
you say بيساوي lint what do you mean by the way guys I will translate what he's saying just wait for him to finish what do you mean by lens بيساوي lens
اوكي. رقم 1 اللي على يمينه
this
معناها بيساوي اللي على يمينه بقى، دوت بيساوي الاندكس بتاعه 2، يعني لينس ناقص 1. معلش يعني ممكن نظبطها ده بعدين، بس بقول لك الفكره. اللينس ناقص 1 اللي قبليه بيساوي
okay
0.
okay just say that you're gonna check here and check here right
left برضه
and check here
yes. If
okay
there is
so you checking here checking here checking here and basically you are gonna take this 0 and add 1 right
لو في 0 وهنضيف 1 عشان كده خلاص لقينا الزيرو. لو ما
so
لقيناش
0 1 so you're gonna add it here which is 1
تمام، مفيش بقى ولا
and if it was 0 here you're gonna do what you gonna do if it's 0 here
لو مفيش ولا 0 لا يمين ولا شمال هنشيك الاول على الثلاثه، ثلاثه يمين شمال above right
yeah
left.
so let's say there is 1 1 1 and there is 0 here and 1 or like 20 here. How do you gonna get this here?
اوكي عايزين نحط حاجه هنا، دوت دي اصلا 0 هنحط 0 بس، احنا مش هنشيك هنلاقي فيه 0 وهو اصلا لو 0 هنضيف 0.
No,
لو
like he said this is 1 not 0. You want to
اقرب
check
0
this is 1.
اقرب 0 يعني هو لو 0 مش هنضيف 0 على طول.
لا no but what if this is 1
على العموم هو لو اقرب 0 هيبقى معانا نفس الموضوع، هيبقى معانا نفس الكلام، فوقيه 0 هنتشيك فوق وهنتشيك شمال.
no
لقينا فوقيه
he said the above 1 it's 1 also so did you
okay
understand?
let's do it so this is 1
yes
this is 1 this is 1
okay
1 1
so the
1 this is 20 and this is 0
only 0
when I'm here how do I'm gonna do it
Excuse me, please.
yes
A binary matrix, is it possible to have 20 or is it just 0 and 1?
it can have any value right I think it have any value
I think this is it. Okay.
yes it can have any value
اللي انت عملته ده كده
yes so like 1
Please
okay, let me
confirm it
explain
again.
to others what you're saying so it's basically saying when we're gonna go to the cell that you want to count 0 so we're just gonna like traverse all the cells so if we traverse to this and we find 0 what we're gonna do we're gonna add to that 0 1 plus 1 and that value we're gonna add it here
هذا على طول بزود variable.
if 0 here we're gonna go here add it here but somehow we need to add the nearest Mahmoud
what
we need to add the nearest like if this one is 2 and this one give us 1, we need to add the 1, not the 2. But I don't think it will work if we have 0 here and 20 here. How are we gonna do this?
لو عايز تضيف مكان الزيرو هنا جنب ال20 جنب ال20 الزيرو اللي
So-
فيها زيرو.
Yeah, so how are we gonna get 0 here? So this should be 2. The nearest 0 is 2. Is 2. How are we gonna do it?
لا هنا هنا اصلا هنبقى عدينا على اللي فوق خلاص، يعني احنا كده كده ماشيين من اللي فوق لتحت، فاحنا عدينا على اللي فوق. انت قلت لو اللي فوق كله بواحد صح؟ انت غيرت كده لو كله فوق واحد والشمال هنا واحد واحد وواحد 20 زيرو. المفروض ان هنا نحط 1 2 اللي فوق.
Okay.
كده.
Okay. Okay, what was the other idea?
Yeah.
What was the other idea? Someone said array, we put all the one. Okay, so there is one optimized idea. Is like the BFS. So like BFS is kinda made to these problems. If you remember when we're dealing with matrix,
No.
we launch a BFS on each cell and it check all the neighbors, right? So it's gonna be the same here. If we let me remove this.
تحت 20 بس ازاي؟
So if we launch BFS on this one, if we launch oh my god. So if we launch BFS on this cell, it's gonna check the neighbors, right? The 4 neighbors. And basically, okay, we don't need this, right? So don't need this. Can do this.
I think
So basically it's gonna go like this. Check this cell and its neighbor, check this cell and neighbor, then check this cell and neighbor, check this cell and neighbor. So with BFS we can do this, right? So we can use this to our advantage. Now the question, do we focus on the 0 or we focus on 1? Do
ممكن
we just like add to the queue 0, or we ignore 0 and add the 1? Because who is gonna change? I think the 1 gonna change, right? So here is one of possible solution. Okay, let's design it. So we're gonna launch DFS on each cell. Let me write it.
I think there is not 20 here and another chip
So
because
okay, let me design this array somewhere here. So I can
can you add the link problem Munsif?
okay, boss. Okay, it is in the chat.
Thanks bro.
You too, brother. So this is our array, right? Did you see the link? So there is one of way we can do it is what we're gonna convert these numbers to how to say it. So with BFS we use Q, right? Before we use the Q, or like we're gonna loop on all the cells, and we're gonna add 0 to the queue. So we're gonna add this one, 0, 0, 0. When we're gonna reach to some variable, let's say something that's different than 0, let's say 2543. When we're gonna reach to this 20, what we're gonna do is we're gonna put a flag here. Like we need to flag it somehow, right? To know that this is different than 0, and we need, this is the one that we need to put 1 on it, or to calculate the difference to, or like the distance to 0. One of the flag way is the infinite number, because it's gonna be easy to compare this number. So if I put a string, if I put x, I can't compare 0 with x, so it will be easy if I put infinite number. So I infinite positive, which means like the max number possible. I'm gonna put it here just to mark that, okay, this one, it have different value from 0. I'm gonna go to this one, 0. So I'm gonna add it also to the queue, this one. Later I'm gonna trace this queue. Now I'm just looping first loop on the matrix, exploring what's inside. Now going to this one, it have 5. I'm gonna remove the 5, and I'm gonna put infinite number. Think of it like a flag. Again, I'm gonna remove the 4 and 3, put infinite number. Mahmoud, you have helicopter in your mic.
What?
So we did add all the 5 0. Now that we add them, what we're gonna do is we're gonna use this BFS on all these cells that we added. So BFS is gonna start from the queue. Now let's start with the first node, this one. Okay, put this blue. Okay, so let's start with this one. Now this is outside of range. Outside of range we don't care about. So this 0, I have this. So this is the key of the algorithm that we will do the treatment of calculating distance. It's this part where we're gonna loop on each 0, and we're gonna check the neighbors that are different from 0. But the way we're gonna do it is like, so we're gonna think about the red one is the main node, right? Think about this as the main node, or as we go through main node. And think about the green one as neighbor. And now we are going through each node, and we are asking this question: if the value of neighbor was bigger than the main node, we're gonna update the neighbor. I will explain. By adding 1, so the distance, right? 1 main value plus 1. So this is important key. Now I'm gonna try to explain. So if the value of neighbor was bigger than the main node, we're gonna update the neighbor by adding 1 the main value plus 1. So the main node and neighbor. the red one is the main one, right? And this is neighbor. So we're gonna ask the same question. Okay, so this is 0, and we're gonna treat the first neighbor. Okay, this will have 2 neighbor. Let's put some here to make it easy. So the first neighbor, the second neighbor. So we're gonna go to this neighbor. We're gonna ask if the value of neighbor, which is in this case is 0, was bigger than the main node. It's not bigger. We're gonna update it. We're gonna update the neighbor if it was bigger. Let me write formula so it will make sense. So if value of neighbor bigger than main value, main value.
May I ask a
Miss again?
question? Would we write it main value compare with the main value or with 0?
Back. So the value of neighbor was bigger than the main node. We're gonna update the neighbor by adding 1.
I thought it wouldn't matter if the main one is its value is 1 or 20. But aren't we comparing with 0?
So like this one here is just the distance, because the distance between this node and this node is 1. So it's like we're gonna, how to say, so if this is 0, okay, let me do a simulation so it become more simple. So let's do simulation here and we keep that value. So this one is 0, right? And now we are treating the neighbor, which is this and this. Now we are asking if the neighbor, the value of neighbor is bigger than the main value. It's not, right? They are the same. So this is gonna stay the same. It's gonna stay 0. We're not gonna treat it. It's gonna stay the same.
What if the main value was like another number, not 0?
It's
the
here.
neighbor was 0. Yeah.
So if the neighbor is bigger than 0, like for example if it was here, infinite, what's gonna happen is we're gonna do the same formula, which is by adding main value. The main value here is what? 0, right?
Right.
Plus 1. It is what? It is 1. So I'm gonna put 1. So if the value of neighbor was bigger, because we did infinite, right? It is the way we're gonna detect the cell that we need to change. So if the value of neighbor was bigger than the main node, which is this one, we're gonna update neighbor, which is this one right here, by adding 1 to the main value of it. So main value was 0, we're gonna add 1. This is gonna make sense more later when we're gonna have we're gonna add to the same cell twice. So we need like memorize the old value that we add.
Okay, thank you.
Yeah, I will try to go on each one. It will make more sense. Now it's still gonna be confusing. It's normal.
I think, yeah, when I see the other example, I will see the bigger picture. Thank you.
Yeah. So we're gonna access let me write it here. We're gonna access neighbors of all 0. Okay, and when we're gonna access them, we're gonna check if the value of neighbor was bigger than the main node. Okay, this is a condition. What we're gonna do if yes, we're gonna update the neighbor by adding 1, the main value plus 1. And after we do that, when we update the neighbor itself, add the neighbor that we update to the queue. So this one that we update, if we did update it, we're gonna add it to the queue right here, because this one itself have neighbors, right? So the neighbors need to be updated, right? So any node that we change, we need to update also its neighbors. So we're gonna keep adding them to the queue to make sure that any update we did, we also, it reflects on the others neighbors of the node. Okay, let's keep going, and it will make more sense after. By adding this, we said add it. Wait, where that was? Add the neighbor that we update to the queue. If the value is bigger, okay, so this is inside, and this is so 210. Okay, so this is basically the algorithm. Now let's do simulation, see if this work or makes sense. So let's start from the beginning. We say 0, and then we check the neighbor first one. We said, is this the value of neighbor bigger than the main node? No, it's not. Okay, it's gonna stay the same. The second neighbor, is this value bigger than the first node? No. The main node, it's gonna stay same. Okay, 0. Okay, move the DFS one step. Let me clean this. Okay, here is it. This one, how many neighbors it have? This one, and this one, right? It have 3. Now we understand this one gonna stay the same because it's 0, 0. This one gonna stay same because it's 0, 0, right? But this one is bigger because it have infinite, right? So we're gonna ask the question is like, if the value of neighbor, this one, was bigger than the main node, which is this one, right? So the purple one is the main node, neighbor is green. So purple one, the neighbor is bigger than the main node. What's gonna happen? We're gonna update the neighbor, which is this one. What we're gonna update it with? By adding 1 to it. What 1 to what? The main value plus 1. The main value is 0. So 0 plus 1 equal 1. So here we're gonna put 1. Now why it's complicated? Why not just put 1? Because later we're gonna be in some edge case where we will need this main value right here. We need to catch it because this main value here, it will help us to find when there is more than one step to the 0. So if it was, for example, if it was here 1 and here 0, then 1, what's the value gonna be here? It's gonna be 2. But by using this way, we can take advantage of this 1, and then I'm gonna do 1 plus 1, 1 plus 1, and it's gonna take me 2. Okay, this, I think I did go ahead a lot. Let's slow down. this will make sense after. It's okay. Let's go back to the safe place that we understand it. So the safe place was, because this is bigger than this, I will update it. If the value of neighbor was bigger than the main node, add 1 to it, mean value plus 1. Okay, so the main value is 0, 0 plus 1, it is 1. Okay, so far the algorithm is working fine, nice. Now we saw this one, we didn't touch it, so it stayed the same. Right, because this one is 0, so it's gonna stay the same. Now we're gonna move to this one. Now when we are here, we're gonna have 2 neighbors, both of them are 0, so they are not bigger, so they're gonna stay the same. So this is 0. We're gonna go here, this is 0, this is not 0, this is what's it called, this is bigger. So here we're gonna compare, is this, so this is, this one did change, so I probably should reflect, probably should write it here. So we did change this to 1, right? Right here. Probably should write it here so we can not get confused. We're gonna ask the same question. If this one bigger than this, it not. Now I did miss something here. When we compare, when we say neighbor was bigger, we compare it with this. Okay, let me write the calculation. It's gonna be if neighbor value greater than min plus 1. So this is the formula. If neighbor value bigger than main value plus 1, because it's like saying or like, let's say it's just normally, is this okay? So there is 0 here, right? And then I'm gonna check what's the correct value supposed to be here. It's supposed to be 1, right? Because there is 1 distance, right? So I will put 1. I will put 1 here. Now that there is already 1 there, we don't need to put anything. Okay, maybe it confuse you guys. Let me try to repeat it. So we did go here, and here there was already 1. Now I'm comparing this neighbor with this neighbor with this neighbor. Who starts from this? This one is 0. We didn't check it, right? We are comparing this. We are checking the cells that are bigger than the distance, or like the bigger than the value plus 1, which is the distance. So in this case, gonna be we're gonna check this. We're gonna see if the main value, which is here 0, plus 1, because we have 1 distance, is it bigger than 1? It is false, so we're not gonna check this. It's gonna stay the same, which makes sense, right? Because it's 1, which is the correct value. There is 1 distance between this cell and this cell. Okay, we're gonna go to the second or the third neighbor. Now the third neighbor is I, which is a bigger number. So if we did the same formula, is like 0 plus 1 bigger than I, it's false. Sorry, I need to flip this. Oh my god, I always flip this. If the neighbor bigger, not the... So if the neighbor bigger than the main node value plus 1, If it is true, which is in this case true, we're gonna enter here. We're gonna update neighbor by adding 1, main value plus 1. So let's update it here. Main value is 0 plus 1 is 1, which is what we want, right? 1. Now we're gonna move again 1 here. Now we have 0, 0, 0, so we don't need to care about these zeros, right? Neighbor that have 0. We're gonna care about this one that's bigger than the main node, right? Because the main node here, what value it have is it have 1, so we're gonna add 1 for distance, and we're gonna check if it's bigger than I. So this node right here, if it is bigger than I, we're gonna say 2 is 2 bigger than I, or like is I. Okay, I keep flipping this, sorry guys. So if the neighbor value, which is I, bigger than 2, it is true, so we're gonna change this. We're gonna update the neighbor by adding 1 main value plus 1. Here's the magic of this. Now the main value here is gonna be 2. Now this is the magic part. By using this formula of main plus 1, we actually got 2 that we're looking for, right? Because this one is already close to 1 of 0, so there is no need to traverse manually, like go up, down, left. We can just check this is the main value of this node and add 1 to it. So if it was 0, which means this node itself is 0. Okay, so I will just add 1 and say, okay, I'm close by 1. If it was 1, what that mean? It means that this cell itself close to some 0 somewhere here by 1 distance. So I can take this value and add to it 1 and take it as a reference, and then it's giving me 2. This way I don't need to look here, I can just look here. Let's try to slow down. It's okay, we're gonna repeat this example one more time. It will make more sense. Okay, so we said we were here. Okay. I can. Okay, so we were here. We moved to this one, and this one was I, right? And we asked the same question. Okay, is the main is the neighbor bigger than the main node? Yes, it have infinite number. Okay, so I need to update it, right? Because I did mark it intentionally as infinite number, so I can understand that. Okay, so this is the cell that I need to update. Okay, nice. Okay, how I'm gonna update it? The formula is like, okay, if it was bigger than the main node, what you're gonna do is you're gonna take the value of main node, wherever it is, the value of main node, which in this case is 1, and you're gonna add to it 1. Why? Because the distance between this and this is 1. Okay, by why I'm taking the main value? Because if this have 1, it means that this is close to some 0 by 1. So it did the work for me. So if it have 3, what that mean? It means that this cell is close to some 0 by 3. Like maybe there's some 0 here. 1, 2, 3. So that is the main part. I hope it's clear. I hope it gets clear more. Okay, so we move we update this by 2, right? So 1 plus 1, and we move to this one right here. We move to this. Wait, I think I did a mistake, I forgot. We said that every time we update, we add to the queue. I did not add to the queue, so we did update this one. So let's add it to the queue here. Okay, let's say this is the middle one, and we update also this one, right? So let's add it here. Here it is to the queue, and then we update this one right here, 2. It's become 2. So let's add it to the queue right here, and now we are gonna go to the next cell, and we're gonna check the neighbors. So we have this neighbor is 0, we don't care about. We have this neighbor is 1, which is the correct distance, right? 0 and 1, it's the same, so we don't care about. Right? We're not gonna put it 2 or something, it's correct, distance is the same. Now we have 1 outside the range we don't care about, and now we have 1 that's answer our question if the neighbor value, which is I, bigger than the main value plus 1. Yes, much bigger. So we're gonna enter, we're gonna update the neighbor, which is this one, by adding 1 to the main value. So main value plus 1, which this one is 0, main value, and we're gonna add 1, so it's gonna become 1 there. So this become 2, this become 1. I also forget to keep popping this, because each time we loop on this, we actually pop them from queue. So we did pop this one, we pop this, pop this, pop this. So these 3 we pop them and we treat them. We pop this 0, we pop this 0. No, there wasn't 0. This is 0 that we pop. We're treating now. Okay, so I did a mistake here. So I shouldn't trace this one because it was after the queue. Okay, how we can recover from here? Okay, we can just do okay, let's do it quickly. Let's remove this. I don't think it's gonna create a problem, but it might create a problem in simulation. So we're gonna put this here. Okay, it's also good opportunity to explain maybe. Okay, so we go to here, we pop this. Okay, here is it, we pop it, and we didn't change anything here because they are not bigger. We go to here, we pop it, and then we calculate this I, because this I neighbor is bigger than this. We calculate, we found out that there is space 1. The distance is 1, right? So 0 plus 1, we put the value here, we move here. Okay, we change this. Okay, we need to add it to the queue, 1, right? Now we're gonna go to this one, we're gonna pop it, and this one is this one right here. This one neighbors all 0, we're not gonna touch them. And we go to here, so we're gonna pop it. Now this one is 0, this one is I, this one is 1. Now this one is the correct value, right? So we're not gonna touch it because we're not gonna enter this formula. This formula is saying if the neighbor value, which is in this case is 1, is bigger than the main value plus 1. Main value is 0, plus 1 is 1, and 1 is not bigger than 1, so it's false. So you're not gonna touch this. And we still have this right here, which we're gonna apply the same formula. This one is bigger than the main, so we're gonna change it. what's the new value we're gonna put is the main value plus 1. So main value is 0 plus 1 is 1, so it's gonna become 1. And because we changed this cell, we're gonna add it to the queue because we're gonna treat it later. Because BFS gonna keep looping on the queue as long the queue is have something. Now we're gonna move to the next cell. No, we're not gonna move to the next cell because remember where this movement is coming from the queue. So I am here, that means I'm working on this. Now I'm gonna go to this, which is this one right here. So this gonna jump to here. Now that was the mistake I did before. If I jump to this, I mean I'm treating this, but in queue we treat one by one, right? So that from here I'm gonna jump to here until I finish all the 0. Then if there's something in the queue, I'm gonna treat it. So I go here, I'm gonna check the neighbor, this one 0, this one outside of limits, this I have this 2 I need to check. I'm gonna check this one already 1, and this correct distance, so I'm not gonna check it. I'm not gonna change it, but this one is infinite and there is only one space here, so we need to change this. So I'm gonna update this one and I'm gonna put 1, which is 0 plus 1. Okay, here is it, 1. And because I change it, I will add it to the queue. This one, I'm gonna add this to the queue. And I will move again. We did pop this and treat it. Now when I'm gonna move to this one. Now, which is the first one we change is the middle, right? So I'm gonna go back here. Welcome in guys. So I'm gonna go back here. And so I'm gonna pop this, I'm gonna treat it. We're gonna do the same treatment that we did before. So this is the same algorithm. We're gonna ask, this one is 0, this one is 0, this one is 0, and this one is infinite. But let's ask the same question, see if it's gonna work or not. If we apply it on this, if the neighbor value, what is the neighbor value, 0, is bigger than the main value plus 1, what is the main value is 1 plus 1 is 2. Is this correct? It's false. So we're not gonna enter here, we're not gonna enter here, we're not gonna enter here. But if we apply it to here, it is neighbor value infinite, and 1 plus 1 is 2. Right? So this is true. So we're gonna enter in this neighbor, we're gonna process it, which means we're gonna change it. So what we're gonna do to it, we're gonna update the neighbor, okay, this one, by adding 1 to, let me rewrite this, by adding main, or like by assigning value main value plus 1. This one is more clear. We're saying I'm gonna assign to this cell the main value, right? The main is purple, remember that? So this is the main, 1 plus 1, which is 2. Right? And that's what we're looking for, right? And what that mean basically, it's mean, okay, this cell right here, the closest 0 to it is by 2 steps. So 1, 2, 1, 2, or 1, 2. But we didn't go through all the cell, we just like, it's like we ask this cell, it's like we ask her like, hey, what is the closest 0 to you? And the cell said 1. Okay, if the closest 0 to you is 1, that mean, and I am close to you by 1, that means 1 plus 1 is 2. So this is basically what we're doing. And then we said we pop this one, we treat it, we treat all the neighbors. Now we're gonna move to what? To the next one. If you remember correctly, this one was the next one that we treat. So we're gonna pop it first. Okay, we're gonna treat it. We're gonna ask the same thing. Let me try to clean this. Okay. Okay, so there's one, there was two here. Okay, so we did go here. Don't need this. Okay, where did it go? We're here. Okay, so we're gonna ask same question, right? We're gonna ask if the neighbor value is bigger than main value plus 1. So this one is not. Basically, it's 0, 0, this outside. So I have this 2 here. So is 2 bigger than the main value, which is 1 plus 1? False, right? 2 is not bigger than 2, right? So it's false. So we're not gonna change anything here. It's gonna stay the same. And then we're gonna pop the next element 1, which is this one. But I forgot something when I update it. Did I update 2? Yeah, I should have 2 here.
Yes, we have to,
When
we
I,
have to
so
add.
yeah, so 2 also should be in queue because I didn't add it. So we're gonna go to the next one, which is here. We're gonna ask the same question. 0 outside of range, and this is 2, and 2 is not bigger than 2, so I'm not gonna do anything. Then we're gonna pop 2, and we're gonna pop 2. We're gonna ask the same question. This 1, 1, 1, 1, they are not bigger, so it's gonna stay same, and the algorithm's gonna finish here. And then we're gonna have this array, which it is the same. Now, please don't think I'm smart because I didn't come with this algorithm. I just learned it. And yeah, and as long as I understand how it works, I'm happy. Okay, so basically 0, 0, right? 0, 1, 0, 0, 1, 0, 1, 2, 1, 1, 2, 1. So this is like the most efficient way to deal with this problem. Now, who did not understand how the algorithm work, or which part are you confused about? I can repeat. Want to be shy, just open mic talk or write in chat. It's okay, you can ask 10 times, 20 times. We are here to learn. Like,
I seriously never understand how
Can you
this
repeat,
is
please?
even going.
Can you
I
repeat,
say
please?
I don't understand the algorithm properly.
Okay, is there like a specific part or?
Okay, let me just tell you what I understand first.
Wait,
Okay, the
can you?
part where I understand.
Yeah, go ahead, please.
The part where I understand is how you how do I put it, add values to maybe when we have a particular number, let's say 2 in a particular index, and then that value is less than 0, sorry, it's greater than 0, we just change the number to 1 based on the closest distance of a 0 from that location, and then we'll pop it from the queue which we had. But what I'm thinking is this, that what if it is not a 3 by 3 matrix? What if it is a 5 by 5 matrix or a 7 by 7 matrix? Well, it will become more difficult, except we'll be iterating throughout a particular like a particular list or a sub list or something like that. So that is getting me a little bit confused.
But did you understand this one, tree matrix?
No, I'm just trying to grab this stuff. It's kind of difficult to understand.
Yeah, but like you need to understand small one before you jump to the big one.
Yes, exactly. If you can just come again just one more time, I'll be happy. Thank you.
Okay, the big one or the small one?
Small one.
Okay, but which part you didn't understand well? It's like where you are confused about. Okay, I guess silence mean I'm confused about everything, right?
You just come again. Thank you.
Okay, so let me repeat it. So, let's remove this. Alright, let's put them here. I will try to repeat just quickly, just because of time, and then later you can watch recording, right? So the idea of this algorithm is like we're gonna move on each cell. So the first we're gonna add the first, like we're gonna turn all the value, all other values that are different from 0 to infinite, right? Now that we have infinite, we flag them, right? Now that we flag them, we're gonna use BFS to go through each 0 that we add to the queue, and what we're gonna do is we're gonna keep treating 0 by 0. So we pop in 0 by 0, and during this pop in the 0, we are also updating the distance. For example, when I am here, I can see that 0 and 1 have distance 1, so I'm gonna put 1 here. When I am here, right here, I can see that 0 and 1 have distance 1. When I am here, I can see that 0 and 1 have distance 1, which is correct, but this one is infinite, so I need to change it to 1. And when I am here and they see that this is infinite, what I'm gonna do is I'm gonna take the value of this one, and add to it 1, and that's gonna be 2. Now how we did it, because when we're processing this one, we are using the same algorithm. The algorithm is saying when the neighbor value is bigger than the main, right? Which in this case is bigger, right? Because infinite, and this one have 1. What you're gonna do is you're gonna put the main value, which is 1, and you're gonna add to it 1, and then put this value to here, 2. Because what infinite mean? It means this one of the cell that we need to update, right? That's why we flag them. Yeah, so that's the key of the algorithm. We're just gonna keep looping through each one, and we updated them. I'm sure if like you try to watch recording again, you will understand.
Got it already. Thank you.
Okay. Who have any question? Don't be shy. Okay. There's no question. Let's try to code this, or let's make it as a code. Okay, we're gonna split this right here, just to keep it as a reference. And let's make cancel. Let me zoom. Okay, so this is BFS, right? Okay, so okay, how we can code it? We're gonna first we need to loop. We said first if you remember, the first part of the algorithm is, let me remove this. The first part is add 0 to the queue, and then change cell that are not 0 to infinite. So this is the main point. We're gonna do this, then we're gonna start BFS. Then start BFS, and inside BFS we're gonna do this treatment right here, which gonna keep popping the elements from the queue and process them. Now to do this, it is a loop, right? Because I need to loop on all the matrix to check each cell and add 0 to the queue, which is this one, the queue. So first we need the queue. The queue in Python, we do it in the queue. So from collection, not sure if is correct. Import DQ. You can correct it if it was wrong. So we bring the DQ from the library collection. Then we're gonna create a variable Q, which is this one, Q, and we're gonna make it as a key or DQ or Q. Now we're gonna loop on each array. Now to loop on each array, we need to know how many rows and how many column, right? So let's get that. Let's call it rows, and let's do it as a tuple column, or like whatever. Let's do it line by line. So the rows are the length of the matrix, right? Because the matrix is like this. It's array and have column, first row, second row, third row. So if I calculate the length of the matrix itself, it's gonna give me how many rows. Length of, here we have mat, so matrix. And colon, let's call it calls. And then calls is if I did access, so this is the colon, right? So if this is have 3 elements, if I access it and I check the length of this one inside it, one of them is gonna give me the length of how many column, right? If it say 3, it means I have 3. So length of the matrix index 0, for example, right? Now that I have the length of the column and matrix, I can just create 2 loop and nest them, and I can then loop on each element. So first loop for let's say a row in range of rows. So one gonna loop on rows, so it's gonna jump to this, it's gonna jump to this one, then this one, then this one, and each one I'm gonna loop in, I'm gonna have another for loop that's loop on the inside. Okay, and then for call, let's just call it RC, in range of columns. Okay, now we're gonna loop on each row. When I'm gonna find 0, what I'm gonna do? If the mat R C, so I'm gonna access this value. I'm gonna check if it's equal 0. I'm gonna add it to the queue. So queue append. Okay, queue append. We're gonna add it. What we're gonna add? We're gonna add the 0, 0, right? The coordination of it, which is R and C. Let's add it like a tuple, R, C. Now, if else, which means it's not 0, which can be any number, we said we're gonna put infinite, right? So mat in that coordination infinite, so we can do it with like float and then inf. Now these 2 loop, they're gonna transfer this array matrix, or like let's call it, they're gonna okay, maybe I put it like this. They're gonna put it all 0 and 1, so it's gonna be 0, 0, 0, 0, 0, infinite, 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 infinite. So that's what happened. And then we have a queue that have all the 0, right? Because this one, wherever it finds 0, it's added to the queue. Now we have the queue. Now we're gonna go to our queue, using BFS, we should always start with a while, right? It's like saying while Q is having some elements inside, do something. What is that something? Is what we define here. So we're gonna just follow this logic. We can access neighbor of all 0. Okay, for example, this one. Okay, to process this one, we're gonna need to puppet, right? Let's puppet. Q pop left. Okay, we got this element. Now this element is have a tuple, right? When we add it as tuple rc. So let's extract it, or so rc. Let's create tuple variable that's gonna hold it. So r, it's gonna have the value of r, and c, it's gonna have value of c. And now we're gonna do that thing. Where is it? Oh, I lost it. Okay, you know that thing where I did a red circle and one hair, one hair, hair, one hair. Let me design it. So in BFS with matrix, you're gonna use this a lot, which is direction. It's like when you are treating the main node, when you are treating the main node, you are like using this. You're moving from this to this to this to this. So like when I pop this node, I'm gonna need this direction, right? Which means, so what is the direction of this? It is this one. Let's write it here. Direction, because we're gonna need them. So directions. That's direction is what's gonna allow us to move on each neighbors. Let's put some like an array, and we're gonna put the first direction is let's say we have r, which is a row, and we have column. Now we are here, let's say column 1, which is this one. So row gonna stay 0,
Maybe C plus
and
1.
1,
Yeah.
and then 0, 0 minus 1. Sorry, the comma minus 1, which is this one, right? If this was 0, 0, right, this red, this one is gonna be 0 minus 1. This one 0 plus 1. This one minus 1, 0. And this one is 1, 0. So this is coordination, because I'm gonna add them to this. And if I keep adding them, I'm gonna keep moving between.
Now
And
you
never.
have to flip them, yeah. Switch the 0 and 1.
1, 0, minus 1. So I set up this direction, this array, so we can, when we loop in on neighbors, we can use them. Okay, so now we have this direction. Probably shouldn't put them here. It doesn't, I mean, they are static, so there is no need to keep every time loop on them. Now we're gonna create a loop for, because we're not gonna pop this, we wanna loop on this direction. So for, let's say direction of row and direction of column in direction. So this loop gonna loop on each direction, and gonna put 0 on the row and 1 on this, which we're gonna use later. Now we're gonna need to add this direction to the one that we pop, right? Because if I am here and I am here right here, what is this direction? This direction is like 0 1 0 1. It's gonna be 1 1. Now to move one step right, I need to increase the C. So 1 1 2. Basically I did this plus 0 1. If I did 0 1, which is this one right here, so I will do this old direction with new one. I'm gonna end up in the right. So basically the new direction gonna be the new row and the new column. 1 second. Back. So the new row, new column gonna be air, which is this one, air, plus this one, right? Which is, we put it in where did we put it? In the air, and the new column, it's gonna be in sorry, it's gonna be this, which is C plus DC, which is this one. It's like saying DC is this. Each time we loop, it's gonna take this value, and DR, each time we loop, it's gonna take this value, and we keep adding them to this. And this one is the value of each node each time we pop new node. And basically like this, we keep checking the neighbors. Okay, pop. Now we have this. So far we can loop on each element. We go to each element, we are able to move to each neighbor. Now when we're gonna move to the neighbor, what we supposed to do? Let's check it. We said we can access neighbor if the value of neighbor was bigger than the main node. Okay, so we're gonna do this condition. How we're gonna do it? We said if, now we need to add something here, is notice that this one, it access also the node that are outside of the limit of the matrix, right? Now we need somehow to limit this, doesn't access. We need to add if condition here, saying if to limit an error, which is the row, the new row. So the row should be so how we can limit the row? We can say we have rows, which it say how many rows we have. We have 3, right? And the row is gonna start from 0, right? Row 0 to 3. So if it was, it should be if, only if, enter here, only if it was between 0 and rows.
0 to 2.
What?
0 to 3 or 0 to 2?
0 to 0 1 2. 0 1 2. Sorry, the index. Yeah. 0 1 2. Right? 0 1 2. Okay. Is that correct? I'm confused. 0 and the rows. Okay, maybe it's correct. If 0 rows, okay, rows. What the value of rows? Length of mat. How many it's gonna be? Gonna be 3. They supposed to do -1? Maybe. Oh no, because we're doing here, we can do greater, not greater than equal, right? So this gonna be 3, the value 3, but I'm doing greater here, which is saying that it should be limited on 2. And we're gonna also do the same for columns. So 0 in C and cores. So like this, we limit the limit of matrix. Now we're gonna go to the algorithm, which say check if the neighbor value is greater than the main value plus 1. So if how I can get the neighbor value, it is this one, right? And I have the new coordination for this, which is what we set up here. So mat, which is my matrix, and I'm gonna access to the row with the new row coordination and new column coordination. Like this, I can access this, and if the neighbor value, which is this one, what greater than the main value plus 1. Okay, greater, here is it, main value. Well, how am can I get the main value, which is this, the one that we check in, the one that we pop? I can get it with this RC, right? So mat RC plus 1, right? Because the distance is 1. Plus 1, right? Because there's no, it's like saying check if this neighbor, the value here is bigger than the main value plus 1. Because if it was bigger, that means it's incorrect. I need to correct it, right? Let's say this is 5. It's like saying the distance between this 0 and this cell is 5 steps. No, it's not, right? So I need to go here and correct it. And by how I'm gonna correct it, I'm gonna put 1. How I can do that? I'm gonna just take this 0 and add to it the steps and put the new value here. Now if this value already have 1, I don't need to process it, right? Because it's not gonna enter here. Now we're gonna, like you say, Abdul, we're gonna append, or like we're gonna append it to queue, but same time we're gonna assign. Let's say this was have 5, value 5. I'm gonna ask if neighbor have value greater than the main node plus 1. Main node is 0 plus 1, and 5 is greater than 0 plus 1. So I'm gonna enter here. I need to correct it. So this neighbor gonna have new value, because the old value that I have, it's incorrect. The new value is the main value plus 1. So the main value, which is this exactly, right here. Now that I correct it, I'm gonna add this neighbor that I update to the queue. So queue append the new coordination in tuple. Okay, is that it? Yeah, that's it. Return, gonna return the matrix because we did change in place. It's possible to create a new matrix and just put everything inside other matrix, but this one we did in place, so we're gonna return this. Now let's see if it's gonna work. Oh my god, this LeetCode did take a long time, right? Oh, it will work? Like I didn't know it's gonna work. It work! It work! It work! I can't believe! No way! We did it! Let's go! Nice. Okay, so please, if you have any question, I can like repeat the explanation. Or if you miss like a big part, you can check the recording. If you just understand the algorithm, it's okay. If you didn't know Python or if you don't know the code parts, if you understand the algorithm, you can do it with any language. If it's clear, we can jump to the second LeetCode. Sabah, you wanna do the second LeetCode?
Yeah, I can take over.
I hope you didn't fall asleep with my explanation.
No,
Okay. I will stop
maybe I
sharing.
should share my screen. Yeah.
Yeah. Take your time until when you're ready. When you're ready, then share screen.
Okay. I'm taking over, still in the PLD, and I'm gonna explain the evaluate reverse polish notation. So reverse polish notation is, I guess, a way of ordering the notation. Simply fixed notation is a mathematical notation in which operators follow their operands. So there is almost a pattern in which the two numbers start first and the operator follows. So 3 plus 4 is written 3, 4, and then the operator is last. So if we can see maybe these examples, we have, for example, 2, 1 plus 3, and times. So we start with the pattern that is the two integers in our case, and then operator after. So we started with this, right? So 2 plus 1, and then that is our value for this. And then this becomes, again, an operand for this. So 3 plus 1 is 3, and then 3, and another 3, and then times. So I guess it's 3 times 3. We can make other examples, I guess. So let's take this, for example.
Okay, by the way,
So
I didn't read the problem. Maybe someone.
Oh, right.
Yeah.
Oh, sorry. So you are given an array of strings tokens that represents an arithmetic expression in reverse polish notation. Evaluate the expression, return an integer that represents the value of the expression. So basically, they're given us an array of different tokens, so integers and the operators, right? And they're asking for us to basically do the operation and return a result. We can note that the valid operators are plus, minus, times, and divide. So we have only these four. We're limited to these four. Each operand may be an integer or another expression. So we are basically guaranteed to either have an integer or an operator of these four, right? The division between two integers always truncates to 0. We'll talk about this later. There will be no division by 0. So basically, we don't have to check if one of them is, or if the divided, I don't know. But if it's divided by 0, we don't have to check that. We can just safely divide by 0, by the other number. The input represents a valid arithmetic expression in reverse polish notation, so we don't have to worry about whether it is valid or not. We know that it will be. And the answer in all arithmetic calculations can be represented in 32-bit integers. So I guess I'm not sure what this means actually. But yeah, we can get to now understanding what this does more. So I guess we can keep our pattern here. So it's always integer 1 and integer 2 and then the operator, right? So these three elements are what constitutes one element of an operation, right? So in example, we have like 3, 2, and plus. It is one operation.
Wait,
In
but
this
there is like
case,
3 number there. How we can? So like if we go for 13, isn't 5 should be a operator?
no, not necessarily, because so this is one singular operation, right? So we have, for example, A plus B, right? This is a singular operation, but the order in which the operands and the operator is this. You have the two numbers first and then the operator last, and you can have as many numbers as you can, and as many as operators as you can, but this is the format in which one singular operation is, right?
Okay.
So in this case you will
But
always be looking for this pattern. Yes.
should we take in consideration the order of operators, like the multiplication becomes before the addition, or not?
I think it takes care of that because it says that it will be valid, but since we don't have actually I'm not sure.
Maybe
But
if we
We
like
have
maybe when like doing the code we can do like check this operator first, then this, so like we start with multiplication, for example, then
I
we
think it can handle that actually, because okay, let's do an example here. So what would it be? So 1 plus okay, I guess 1 times 2 plus 3 times 4. In this reverse Polish notation, it would be I guess 1. Oh, okay.
1 2
So it would be, yes,
1
1 2
2
and then
operand.
times, and it would be 3 4 and
3
then times,
and then plus at the end.
and then plus. Yeah, so it's basically safe from this.
Okay, so the array that you give us in input is already treats the what's it called, the priority, so we don't like
Yeah.
care.
Yeah.
Okay.
So in this case, you would be looking for this pattern, integer operator. So you would go 1 2 and times, and this would be your first operation, and you would replace this with your result, which is 2, right? And then you would keep looking again for this pattern. You would go to 3 and 4 and times, and again you would replace this with your result, 3 times for 12, and then you would finally have this, which is 14. So you keep looking for this pattern in the middle. You keep going until you find 2 integers and an operator, and you solve that equation, replace the 3 elements with that, and then you keep going. Does that make sense?
Okay, I think I get it
So
now.
in this case,
it's like we're gonna loop until we find operand, then we're gonna start calculation.
yes. So each time you find the operand or the operator, you're gonna look for the 2 numbers before it, and that's your 2 integers that you're gonna work with. So even if, for example, you have this big array, you're gonna go until you find your operator, and you're only interested in the 2 integers that like are before it. So basically, you just go through our array one by one. So I guess, does anybody have any issue with that?
Any question? Don't be shy, guys.
Would they give us one number before the operator or not? Just in case.
What do you mean?
I mean, if they give us an array with 4, then plus, then
that would not
another
be
number.
valid. That would
No.
not be valid.
Okay.
It's the same thing as like writing, I guess like in normal, you write like divide by 3. That would not make sense, right? So yeah. So we can use maybe a stack, right? where you go through each element. For example, you would go through each element and you put it in the stack, right? And you keep going and going until you find your operator. And
so
then
we're gonna put
you
them all in
retrieve.
stack?
You keep putting in the stack until you find the operator. And then you retrieve the last two elements that you put and you work with that. You get your results, you put it in the stack and you keep going.
Wait. So you put them all in stack, and then when you find operator, what you do?
You retrieve the last two elements.
Okay,
that
so
you
int
put.
1 and int 2.
Yes. And you do your operation based on whatever operator you have. You replace the whatever integers you have put in your stack. The last two, you replace them with your result, and then you keep going.
Okay, I see. So
That
when
is,
we're gonna
I guess,
retrieve
one way
them,
to do it.
when we're gonna retrieve them, we're gonna have only 4 stay in stack. So like
4?
Yes,
number
exactly.
4. So like let's do example like put 4
Yeah.
and 3.
So we're at 4, right? And we put 4 here, right? Then we skip to 13, and then we have 13 here. You skip to 5, and you have 5. And now that we have an operator, you're gonna retrieve these last two,
Okay.
right?
Okay.
Because these are the elements of your operation. So 5 as int 2, 13 as int 1, right? So you take them.
Yeah, I think it will work.
Yeah, I think so.
So you take them, you do whatever
Okay.
operation you want to do on them, right? So equal.
Eating.
In this case, 13 divided by 5, I think it's.
Oh, divide.
2.
That's
Yes. 13 divided
So
by
5 divided by 13, I think.
No, 13 divided by 5.
Okay. Let's do this. So 2.6. So that's when. Okay, let's roll with this idea, and then we're gonna talk about the division thing. So let's say we round down to 2, and then this 2 is what we're gonna add to our stack.
okay. So
And
the
then we
results
keep
we
going
added.
to 2.
Okay.
Yeah. Then we keep going, and then we have a plus, now an operator. The last two elements of the stack are now 2 and 4. So you take 2 and 4, you do your operator with them, and then it's 6, and you put 6 in your stack, your turn back.
Nice.
I guess that's, yeah, it's
Perfect.
6. Now, there's this issue of truncating towards 0. It means that any division that you do when you have a decimal number, rounding it should always be towards 0. So if you have your so you have 0 here, and you have your decimal number. In this case, we have 2.6. Any rounding that you're gonna do should always be towards 0. So in this case, you would say that you would round down, right? 2.6 rounded down is 2. But in the negative side, minus 2.6 would be rounded towards 0. It's going to be minus 2 instead of rounded down, which is going to be 3, right? In Python, it's a little bit tricky. So if I say minus 13 divided by 5 is minus 2.6, right? If we do the integer division, it's going to be minus 3. So it doesn't truncate towards 0. Math.floor would not work either because it will always floor down, round down. So one way we have found to do this is to use int. Yes?
Sorry, if we said if it's below, if it's a negative number, it's a negative integer, truncating to 0, doesn't it become 3?
No, it would truncate towards 0, so it would round up instead of down, because
Yes, so-
-2 is smaller than 0. -3 is smaller than -2. So it's going up, not down. -3 would be this way.
Okay.
So we
Right.
can use dot sale.
Hmm?
I said we can import math and use math.sale, like SEIL. And then it's going
But
to
the issue with seal is it will work for negatives, but it will not work for positives, because seal on 2.6 is 3, which is not towards 0.
Can we just give it a try? What?
We can check if it's negative or positive and then round appropriately, but there's an easier way, which I'm not really sure why it's different from this, since both are called integer division, but I guess if you do int -13 divided by 5, it truncates towards 0. So there's a difference between this and this, even if both of them round. But this rounds down like normally, and this rounds, I guess this rounds to the nearest, I guess, integer, but this one truncates towards 0.
Let's try the positive of what you just ran.
On int,
Yeah.
it's gonna be 2.
Nice.
Yeah. But there's the way of checking if it's above 0, you use math.floor. If it's below 0, you use math.seal. But I guess this is quicker, faster.
Perfect.
So this is the issue of truncating towards 0. Yeah, otherwise we can start doing some pseudocode.
Yeah, let's do it.
So we're gonna make our stack, right? And then we're gonna loop through the tokens. No, actually no. We're gonna go through the stack, I guess, but we also put the first number in the stack. So add first token to stack, right? And then while the stack
First token
is still
Wait,
full.
why are we gonna add first? Okay, so we're gonna loop after.
Yeah. So it's kind of BFS,
Yeah,
but
just
more.
optimize.
Yeah. And then while the stack is full, we take the, wait, what am I saying?
Or like as long as the stack is have something, like while stack is have some elements, we're gonna keep looping.
It is full.
Yeah, I think it's better to loop through the tokens, because the stack at the end will only have one element. So basically we'll never...
Oh, we're gonna loop on token.
Yeah.
I see.
So we should loop through token. So we loop through tokens, and then we check. So we check if it's an operator or an integer, right? So if int, then we add it to stack. This is the easy one. If it's not, however,
Wait.
Yes.
We loop on the token.
Yes.
If it is int, we're gonna add to stack.
Yes. If it's one of these numbers, then they get added to the stack. It is not.
Wait, isn't that topology string?
Yes, but she would try to convert it into...
Oh, I guess we can convert it. It's not an issue.
Okay, I see. Okay.
So, typecast, then we can add maybe a...
Okay.
I guess a try except.
I just was confused about if int, or
Yeah,
maybe
so
we can
if
add
it's
it
one of the
anyway.
number,
What if we just add it anyway? If it is int, if it is not.
it can be an operator,
Oh,
and
okay, I see.
you
So
don't
we're gonna
add the
cast it maybe.
operators. Either that, or we check
Oh,
if it's
okay.
if it's this first, if it's not first, and do an else. That would be easier because we have a limited number of operators.
Okay, I think that's the genius idea. If we add only, or like check if it is this operand or this, and then else we put all the numbers.
Okay. So if it's one of the operators, then we do something, and then else we add the number to stack. All right. So if it's one of the operators, we are gonna retrieve. So as I said, let's keep the example here close. So we have 4, we have 13, and we have 5, and say we get to the divide, and that would mean that we're gonna retrieve the last 2 elements, right? So retrieve the last 2 elements, and then do our operation, right? So calculate, and then we're gonna replace. So I guess since we retrieved them, we popped them, and then after calculating, we're gonna take that result and add it to the stack. So we add result to stack. Yes, and then we keep looping until there are no tokens. At the end, we will have only one element in our stack, which will be the last result. Now, there's this one. If it's one of the operators, how would we know that?
Maybe we do if else. Like if it is plus, if it not, we go another
Okay.
else. But that's gonna be a lot.
You can
think
also
we just-
create a list with all the different operands and then check if that token is inside that list.
Okay, that's
If
smart.
yes, and yes, right.
That's smart. Put them all in the list and then we check if it's inside
So
the
if
list.
it's plus, if it's minus, if it's divide, if it's times, and then here, now that we know it's one of these, how would we proceed? So we're bound to do that if else, if LF.
Oh, because each operand have calculation. So maybe
Yes.
in the calculate part where we're gonna need if, like the calculate.
But the only striking part is where you have to do the division, isn't it?
Can you repeat?
I mean, the only striking part is where you have to do the division.
Yes, but each operation is different. Here is gonna
Exactly.
do the addition, division.
True,
Yeah.
true.
So it's just a series of if elif.
Exactly.
Maybe not everyone, just because the retrieve last 2 elements gonna be for all of them. We're gonna
Yes.
always retrieve 2. But when we're gonna calculate, we're gonna be like, okay, wait, what operand we have? And then we're gonna say, oh, I have plus. Okay, let's do plus plus, then append. Oh, I have minus. Okay, let's do minus, then append. And
So
when we finish, we
it's
add to the
after
result.
this. So after
don't know if
this, it's this. Yes.
I'm not sure. Maybe.
If possible, can we have a dictionary in such a way that when we have something like a plus that is a key, then we have a plus as a value? I don't know if it's going to work.
Plus as a key
That's a good idea.
and
Yeah,
as
plus
value?
as a plus as a string key, not literal plus.
Yeah, just
Yeah, then we return a plus, an ordinary plus. Yeah, I don't know if it's
just
going to
plus.
work. Yeah, is it going to work?
You've got the right idea, but not the good execution. In here, we can either have maybe functions. So function that adds, function that divides, function that subtracts, and then we can call the function here, right?
Oh,
That's
see.
going to be complicated. That's going to be a bit complicated. Just having the operator will work because we are going to just use the operator while we calculate. That's going to be simple.
So you're telling me. So let's try it here. We have plus.
He said for simplicity, we can make just the elif or switch.
Switch?
Switch case.
I don't think Python has switch case.
Oh, okay. Never mind.
So you said the plus, right, like this?
Dictionary, I don't think so that it will work.
No,
because
that will not work. How
When
do you
we-
save that plus sign?
When
It
we
should be a
get
character instead of the operand.
I don't think it's going to work. I don't think it's going to work too.
That's it's not work. I think the idea of a function is the best one.
Yeah, let's use a function.
There is a third way which uses lambda. And basically you give it x and y, and then it does your operation for you. It returns this. But I guess we can use the function.
No, I think let's use a lambda since it's just a simple
Yeah.
function.
So let's see the lambda Python. So you give it your two params and it returns your okay, it's two, right? And it returns whatever operation you make. So we can do something like this, which is the same as having different functions, right? So in the addition, it would have plus, right? And then for the subtraction, it would have minus, right? And it's the same for division and multiplication. So for the division, we said we're going to use the int since it truncates towards 0. So a divided by b, right? And in here, how do we do it? We call the key.
The key of
The
we
key of
compare
the variable.
the key maybe. We keep comparing the key.
So operators.
Or just
token?
call the key. The
Yeah. So this is our token in our list, I guess, dict operators. I guess like this, maybe.
yeah, we give it arguments A and B, and we need to save it somewhere, right?
So the results equal operators. And now we add this result to the stack.
Okay, how are we gonna add it with append, right?
Yeah.
The push.
Is it clear?
So, I think so. Who have question, please don't be shy.
Okay, I guess if it's If it is clear, then we can
Yeah, I think it's good.
put this into code. So first of all, we create our stack. DQ, I guess?
Yeah, DQ.
And then
You have to import it, I guess.
I mean,
DQ.
it's good practice to import it, but it's in LeetCode. I think they import everything for you.
Oh, really?
okay.
And I'm writing it's like
Yeah.
crazy.
It doesn't. So our operators.
Thank you for letting me know.
And she let you write it every time.
She probably mutes the mic and laughing at me. He doesn't know. Keep going.
So we loop through the tokens. So for token and tokens. So I guess it's a list of strings. If it's one of the operators, so if token and operators, we retrieve the last two elements. So B is gonna be the one at the first one to get retrieved. A is gonna be the second one to be retrieved. So in this case, then B equals stack.pop and A equals stack.pop, right? So now two elements retrieved. Now the result is going to be operators token A and B, and we append
The result.
Append result. Now here, I guess we need to do an int, right? Since they are strings. And we know this is safe and not gonna give us errors because we only append integers to the stack and not, well, I guess not integers, but we only append the numbers to the stack and not the operators. So no need to, I guess, guard it.
Wait, can you repeat that? Can you repeat that?
So int usually returns an error if it's not, I guess, typecastable, right? So if we have these kind of operators in our stack, it will return an error. But we know that we only add the numbers to the stack and not the operators.
Oh, okay.
So we don't need to guard it in case it fails. Yeah, we append stack.append the token. Yeah.
Wait a second.
And I guess,
what if we so what if we in the line 15 we convert them to int, so we don't need to cast it twice in int B?
That's a good idea. Yes.
Oh, I feel smart. Is that how it feels?
So yeah, and then we return the first element of token of the stack. So it's return stack, I guess 0. I guess we need to check if the
why zero?
array is empty. So because
zero?
at the end of our operations, the only element that's gonna be in the stack would be the last result that we need to return.
Okay, I see.
So actually we only have one element. So 0.
Okay.
That's what we return.
Okay, I see. Makes sense.
Okay.
So are we guaranteed that the number of operators that we have and the number of other tokens that we have are actually going to match the exact number?
It's a valid arithmetic expression. So we don't even have to worry about cases like that. We just solve it. We don't worry if it's valid or not.
I see. In case if it wasn't valid, then we're gonna be forced to retrieve the last elements we haven't, or like the last elements that we push.
Yeah. Because the last element that we push is gonna be the result of the last operation that we did.
Okay, I see.
I'm not sure if they're gonna give us empty
Concrete.
like arrays.
Then we need to return what? 0?
I guess. Maybe. Okay, so no. That's not
Okay.
even gonna happen, so that's not even the case.
Okay, let's see if this is
try.
gonna work. Oh,
works.
okay.
Let's just submit it.
Yo, you guys don't clap for me, only for her, right? Okay, I see what's happening.
70%.
Thank you guys, thank you for clapping just for I'm joking.
Okay.
Officially
I
have
think
a PLD host.
Okay, that's really nice. 70%.
the issue is the LFs are faster.
Oh, because we use the lambda.
Yeah. LFs are faster.
Okay, but the lambda look more cleaner. Not nice. Wait, how did they do it with F? Wait, go back to that. Wait, what the hell? Wait, stay here. What was that? Wait a second, go back. Wait, is this real people?
Yeah,
I think so.
Oh my
Please, I
god.
lost it.
I think the one on it must be the one on this
yeah, I
one.
saw so.
Wait.
Add.
Stop. And where did he call that from? Oh, they are default. I think. Oh, there is a default scene in Python. They are built in. Add and sub and multiplication.
True the
I think they are built in. I remember something like this.
What's action T? Oh, action, okay. So you said built-in.
Add and sub, yeah. That's crazy. In Python.
No.
But it works with the dictionary.
Wait.
It does. It does.
Yeah, I thought it will not work.
Okay, maybe give him the code and tell him like what's going on here. What magic spell is this?
Exhibiting. Dictionary action is created, mapping arithmetic operations to their corresponding function from the operator module.
True.
Oh boy.
Dave.
Operator. Great. Add.
Oh, so he did import it. Wait,
Yeah.
go back. Where is the
But
import?
since
Oh, again.
there's no import.
He know. Of course he know. Of course he know. I'm the only one I don't know.
But with the with the LFs, I guess you just do it manually. If plus, then A plus B. If minus, then yeah.
Is this faster than
Yes,
what we did?
because
It is.
yes, because there is the
Sadly, it
lambda.
is.
Lambda
Yeah.
increase
This is
the
very demoralizing.
I'm skeptical.
Sabah,
even
by the way,
faster.
Python in the last edition, or maybe Python 3.10, they add the switch, but not with switch case, but they call it match case. in the new
In
version.
match case?
Yeah.
Python
Oh,
to return.
nice.
It's the same already.
Okay. That's good to know. Thank you. All right. I
You're
think that is it.
That's amazing. Please,
Thank you,
everyone, clap
everyone.
for Sabah. Okay, so so wait, let me share screen just to catch up on what's gonna be the next session before we close it. Okay, so first, thank you, Sabah, for
welcome.
jumping to the stage, and also like anyone that feel wanna explain some LeetCode like Sabah did, you can do that. Just check the planning, see which LeetCode you feel comfortable with to explain. It's not like you don't need to have the solution or something. We can help each other to get through it. So we finish week 7. So we did all this LeetCode, which is amazing. Like we learned so much through this LeetCode. Now we're gonna jump next week to week 8, which gonna be a bit easy because we can do 2 LeetCode Tuesday, 2 LeetCode Wednesday, and 2 LeetCode Saturday, 2 LeetCode Sunday. So if someone feel comfortable with some LeetCode of one of them, do wanna like host it, even 2, even more, feel free, just reach out. That's it. See you next week in Tuesday. Have a good night. Love you all.
Thank you.
Good night, everyone. Good night.
Good night.